In today's video, we are going to overclock the original AT from IBM, the 5170. We have restored this machine in the previous video and overclocked it from 8 MHz to 10. But it's never enough, is it? So let's get the lid off that IBM and see where we left off. Okay, apparently I have snatched some cards and components from this project. Probably to troubleshoot some other machine. But we'll restore it, and then some. But I need to go through my stuff and find these missing ROMs. And a CPU apparently. Although I don't think we're going to use it, because it was probably not fast enough anyways. So I had this machine in storage for quite a long time, in a really grimy condition. Until I finally decided to restore it. And it immediately became one of my favorite IBMs. Prior to the restoration, I had never seen it in a really nice condition. But now that this machine is restored, it looks pretty epic. But looks isn't everything. We also need speed. So let's get that board out and see what we can do. We also have some tantalums on this board that are from 1987. So my estimation is that they're going to start popping in just a few months. The newest tantalums I have that have exploded were from 1986. So just a few months older than these. Once we had restored this machine, it turned out to be in this extremely nice condition. So this machine has been stored really well. And from what I could tell in the restoration video, it had been sparingly used. Oh, we're too late. This guy is already blown. So sometimes they blow the entire top off. But quite often they just blow small holes in the top of the cap. Just large enough to get rid of all the magic smoke. Well, this is a pretty big preheater, but this board is massive. So a large portion of it is actually hanging free and isn't really held down by the clamps. So this is gonna be sketchy. I used an old CPU cooler and some leftover PCBs and stacked them up underneath here. Because if we don't, this board is gonna get bent, so it's basically gonna fall down on this side. So a bit sketchy. I guess I'll do this side here. And then I'll have to move the PCB further in and let this side here hang loose in there. Since this installation is so sketchy, I'm gonna go quite low on temperature. I have set the preheater to 100. Now let's see if that is enough for that massive ground plane in this board. I have marked all the caps underneath the board and a couple of the chips because we're gonna have to replace them. And while the desoldering gun heats up, I'll add some fresh solder to all the legs. And every single leg on every cap is bent. How annoying is this? Unfortunately I can't get closer in with the camera with the board on the preheater. But hopefully you will be able to see this. So since all the pins are bent, I need to use my desoldering needle to straighten them up. So I basically melt the solder and put a desoldering needle on top and straighten the pins up. Even the third pin in the middle is bent. How rude, IBM. And if we don't bend the pins up before we remove the cap, they're going to rip the pads off the board. So this is an absolute must. This board seems to have a really good solder mask. Because despite my wiggling, it doesn't seem to create any scratches on the board. And I noticed something interesting here. I have the preheater set to 100 and it actually reached 100C on both sides quite quickly. So that kind of implies that it doesn't have really thick ground planes inside. Normally I would get 20 degrees less on top of the board than underneath. But not with this board. So that blown cap actually didn't blow during my ownership. So that must mean it blew years ago. That kind of tells us that all tantalum caps from the 80s have to be replaced now. Even on this late 1987 board. 1987, by the way, is the last year of production of these machines. And today we're gonna see if we can make it beat my old Model 50. And the wiggling, by the way, helps the pin to come free from the through hole. But on some old boards you can't wiggle because the solder mask is so crappy. It gets all scratched up. I'm also going to desolder a couple of ICs, because they're not fast enough for overclocking. Before we continue, I'd like to thank the sponsor of this video, PCBWay. Aside from making excellent PCBs, as we have seen in many of my videos, they also do CNC machining, sheet metal fabrication, 3D printing and injection molding. Perfect for prototyping and vintage computer restorations and mods, just like this one. This is just a few projects that we have built on this channel, and there are many more to come. If you have missed the purple PCB promotion in September, you still have a chance, because they have extended the promotion. So you can get your PCBs in purple solder mask with no additional charge during October too. Thank you PCBWay for supporting this channel. Well, it's hard to tell quite yet. But from what I can see so far, 100 was enough for this board. Okay, next I'm going to use the desoldering needle and gently wiggle all the pins to check if they are loose. They seem to be. So next I'm going to turn the preheater down to 50 and let it cool down slowly. Okay, the board has cooled down. And I'm happy to say it didn't get bent, despite my sketchy installation in the preheater. Now let's see if these caps will come off. Yeah, this one totally did. This guy too. And here's our popped cap. And it's still slightly stuck. Yeah, it's still stuck to one of the pads. So let's add some heats. We're in the rework station. I have it set to 400 and airflow to 50, and that was enough to get it unstuck in about 1 second. This board has some bodge wires very nicely installed, and apparently someone made a mistake designing this board. Okay, only one of the caps was stuck, so 100C was clearly enough for this board. Now how about the two ICs? This guy is still stuck. I'm not prying, I'm just gently feeling if it's loose. And it actually is, at least on one side. Yeah, it's totally coming off. Yeah, this chip is loose. Awesome. I'll get back to these ICs in a minute and why I decided to remove them. And the last component is this guy here. Now it's still stuck. And I'm not going to use any force to pry it off, because that could rip one of the pads off. Instead I'm going to put my chip removal tool underneath and then use the rework station to heat the pads up. Now this chip is very close to the CPU socket. I hope it can take the heat. Yeah, now the chip is coming off. Yeah, that totally fixed it. And only took 2 or 3 seconds, so no damage to the CPU socket. Okay, so the desoldering went really well. Beyond expectations, actually. I have recapped a few XTs, and they are a lot tougher than this board. This was actually pretty easy. Okay, let's inspect the pads next. See if they got scratched up. No, they didn't, so IBM used really good solder mask here. I don't actually know if IBM made their own motherboards in 1987. Yeah, these pads look great, but I better take care of the solder blob. So how about the pads for the two ICs? Yeah, this is looking good, and they are completely free from old solder. So that turned out to be a pretty perfect chip removal. Okay, so this board had 3-legged STC branded 10 microfarad 16-volt caps. And I'm going to replace them with these Kyocera branded 10 microfarad 16-volt caps. That only has 2 legs. The board and the original caps are designed to prevent mistakes when they are installed. Because if you install these caps backwards, they will explode quite violently. Unfortunately, these guys have not been standardized. So the two othermost pads here, they are connected together. But then it varies. Sometimes you have the positive in the middle, and sometimes it's the negative. So you basically have to check. And on this board here, the positive is in the middle. I have accidentally managed to crack a couple of these, because if you install them flush to the board, and later grab the board and accidentally push on one of the caps, they will actually crack. So I tend to bend the leads like this. So I bend them out and then back in again. This way they get raised from the board, and if I mistakenly push on them, they will just bend to one side instead of cracking. As you can see, the positive lead is marked on the cap. So that side has to go in the middle through hole. And we can just leave this through hole empty. I'm going to be a very old man when it's time to replace these caps again. So let's be nice to my future self and unbend all the pins before I snip them off. And if you're playing along here, there are 22 of these caps on this board. I imagine a lot of components in the future, like these large tantalum caps, are probably going to be obsolete when it's time to replace them. But I guess we could just use SMD caps and solder them directly to the pads. Or maybe we'll use some fancy polymer caps. That should look pretty crazy on a board like this. And that was actually our last happy cap. This board is so clean, I'm gonna skip the wash and just clean the legs we have soldered. Instead of U82 and U83, I'm going to install two sockets. I'll solder 2 pins roughly in the middle and make sure they sit flush to the board on the other side. And now we can solder the remaining pins. And then I think we're done with this board. But there are a couple of more things we need to check before we start overclocking. Okay, I went through my stuff and found the missing components. So we've got the latest version of the original BIOS in these 2 ROMs here. But unfortunately the original BIOS checks the CPU speed and prevents the system to post if you have overclocked it. So sneaky IBM didn't want us to overclock these boards. But we also have this generic Army BIOS here that couldn't care less how much we overclocked this board. So we might as well install these guys right away. I also found the original CPU that came with this board. It's an IBM branded 286, capable of running at 6 MHz, which clearly isn't enough. So I'm just going to leave it in the machine in case I want to put this board back to original in the future. But we're not going to install it. And then we have the 286 we used in the previous overclocking. This guy is rated for 12 MHz. But we're not going to use it today either, because this chip belongs in another machine, so I need to return it to that project. But we are going to reuse the PLCC socket and install a Harris 286. These guys can go even faster, but the goal today is actually 12 MHz, so this guy here would have been sufficient. But these are spare chips, and one of these guys can stay in the machine. The PLCC socket isn't really designed to be installed in another socket, but we have tried this before and it worked. This way we can just leave the original socket on the board. Okay, let's test as few things as possible in this first test. We have tried the 2 EEPROMs with the BIOS in the previous video. This Harris chip is tested too. And for this test I installed the original U82 and U83. And I kept the original crystal on the board. By the way, there were 3 revisions of this board. And this board is a Type 3. The only difference I am aware of between the Type 2 and Type 3 board is the CPU and the crystal. But there may be other differences that I'm not aware of. The Type 1 board is completely different. Okay. I think we're ready for a test. So let's check and make sure I didn't make any mistakes here. I think we installed an EGA card in this machine when we did a restoration. But I actually have another machine in mind for EGA graphics. So we're going to install a VGA card instead. This is an ET4000AX. I bought this card years ago as new old stock. But it wasn't really a good match for any of my other projects. So this card has been sitting on a shelf. And since we're going to overclock this machine, SA bus is going to be overclocked too. So perhaps a bit of an odd choice for an IBM AT. But I want to give this machine the best possible chance to run at a higher speed. And besides, I can't think of any other projects this card would be a good fit for. I think this is an OEM card. It came sealed in its original bag, but without the box. and the bracket here is a bit funny. Okay, motherboard installed, VGA and a controller, and all 3 drives. Let's turn the machine on and see if it still works. A huge MFM drive woke up with a roar. Okay, the graphics card apparently has 1 meg of display memory. And we have the generic Army BIOS here and a 512K of RAM on the motherboard. And since I removed the battery, all the CMOS settings are lost. So let's run CMOS setup. I'll fix the date later. And our drive A is a 1.44 meg drive. Drive B is 1.2 megs. And we have the original Type 2 drive installed in the machine. Let's do this proper and set it to VGA. And keyboard installed. 0 wait state option is disabled. But unfortunately these boards have 1 wait state. And as far as I know it can't be disabled. Okay, I think that's all we need to set here. So let's save and exit. I can't quite remember, but I think we have installed DOS on the hard drive. And that awesome MFM drive is in great condition. Okay, let's see if we have something on this drive. Okay, no benchmarks. So I'll install something. Okay, I installed Landmark 6 on the hard drive. Let's run it. And as expected, this machine is running at its original 8 MHz. But we have a massive speed increase with the graphics here. I don't remember what we had, but I'll check and insert on the screen here. Well, we already know that this board can do 10 MHz. Now let's see if we can go faster. And that brings us to these mystery chips here that I installed in sockets earlier. So first we have the D82-284-8. This is the clock generator, and it's actually rated for 8 MHz. So we were really lucky to reach 10 in the previous attempt. And I'm going to replace it with this D82C284-12. So this little CMOS chip here can actually go up to 12 MHz. And the other mystery chip here is a D82-288-8. I had to check. So same thing here, we were lucky to reach 10 MHz with these two. And then we need to replace the crystal, of course. But my modern crystals here, they have much thinner leads than the original crystal. But apparently these 3 amp diodes here, they have leads with the same thickness as the original crystals here. So I just snipped those leads off and soldered to my crystal. Okay, 24 MHz crystal installed. Divided by 2, that should give us 12 MHz. I had some trouble installing it, so I had to bend the leads. But this is gonna have to do. And our new U82 and U83 are installed on the board too. Okay, all bets are off. Here goes. Hard drive spun up. Oh no, we're getting nothing on the screen. Oh, that sucks. I was really hoping it would do 12 MHz. But unfortunately I don't think it does. Well, this could be any or many components that won't do 12 MHz in this machine. So let's do a test without the controller installed. Here goes. Ah no, unfortunately, wasn't that easy. Well, let's make sure that this is caused by the higher speed, not something else. I installed the original crystal, I left everything else in. And now it's counting up the RAM. So that is definitely an issue with the faster crystal. Well, in that case, let's jump into BIOS again. And see if we can mess around with the wait states. Well, it's already in the disabled mode. Now this may not have any effects on the motherboard, since this is not the original BIOS. But if it does, it's already set to 1 wait state. Well, we are overclocking the ISA bus, so our issue could actually be the graphics card. I'm not sure exactly how this works, but these cards have a turbo and a normal mode. This card came in normal mode, and I have changed the jumper to run it at turbo mode, because that gave me a significant speed increase. But let's try it in the normal mode and see if that makes a difference. I also noticed that the 2 leads I soldered to the crystal were very close to shorting to the case, so I moved them further out on the leads. Okay, 84,000 in normal mode. And unfortunately, it wasn't that easy. Okay, let's try with the GD5422 next. Here goes. And unfortunately, no change. The other suspect I can think of are two slow RAM chips. So these guys are Mitsubishi M5M 4256P. We're in luck, because I found some faster. The original chips are rated for 150 nanoseconds. And the NEC G41256 chip I found in my stash, they're rated for 120 nanoseconds. So they can go a bit faster. Okay, and apparently this board has parity. So the 16 chips I had, they are actually not enough. But luckily I also have some AOYUE branded. And our luck continues. I decided to check again. And I found some more of those AOYUE branded 100 nanosecond chips. So we can do better than 120. Okay, super fast RAM chips, do your thing. Well, apparently they won't. That is unfortunately not our issue. Still no posts. Well, I guess we should check and make sure those RAM chips are good. And the graphics card too, I suppose. So I install the original crystal again. And it's counting up the RAM. So unfortunately, nothing wrong with those RAM chips or the graphics card. Well, let's not be greedy. Let's try with a 22 point something megahertz crystal next. We already know it runs with a 20 megahertz crystal. And I can hear it counting up the RAM. It's posting. Okay, let's try with the controller and the drive is connected. Okay, still posting. System option not set. Okay, so how the heck did I manage to reset the settings in the BIOS? I didn't disconnect the battery, so this is a bit of a strange behavior, but this is an easy fix. And it boots. Love the sound of that MFM drive. Okay, let's run the benchmarks. Okay, we are running at 11.082 megahertz. Check out the video score. I think it went from about 5,000 to 7,000. So the GD5422 kicks ass, and the score is that this computer performs like a 13 megahertz AT. So I mean, this is not bad. This is a massive improvement from the original 8 megahertz. But let's try some more. Okay, this is the last crystal I have below 24. And this guy here is 22.57. So just slightly faster than the previous crystal. Okay, it's posting. The MFM drive is roaring. And it boots. 11.32 megahertz. So close to 12. Oh man, this sucks. Well, one possibility here is that I have the wrong 24 megahertz crystal. I don't have the datasheet for the original crystal, so maybe I just have the wrong type of crystal. Okay, next I did some research and I actually found something interesting. First I found a more than a decade-old post by a former IBM employee. He claimed that he had managed to get close to 12 megahertz by changing some resistors on the motherboard. Sounds pretty crazy, but we have actually doubled the speed of an IBM PS1 by moving some resistors on the motherboard. So maybe there is something to it. And then I found a tiny picture of this contraption here. Apparently there was something called the XCELX frequency adjuster back in the day, designed specifically for the IBM AT. It looks to be designed to be installed in the unused battery door at the back of the machine. And it's made to change the CPU frequency in many different steps, between 6.5 and 9.5 MHz. That is pretty cool. I'm tempted to build something similar. But this is all I have for you today. Apparently, the mighty IBM AT can do almost 12 MHz. Like, subscribe, leave a comment, and consider supporting me on Patreon. And I'll see you guys again next week.